In the 1990s, what were once thought to be quite natural Arctic events, such as the summer sea ice melt in the Arctic Ocean and the shifting ice sheet patterns in Greenland, were becoming noticeably abnormal. It was becoming clear to observers that temperatures were rising in some parts of the Arctic, but a picture for the bigger Arctic region was unclear. Both scientists and local indigenous communities were becoming increasingly alarmed.
We were getting some numbers of changes in the Arctic that just didn't seem to fit into this slower pattern that we were seeing on the rest of the planet. The indigenous people were saying, hey, something's going on up here that's quite different, quite unusual. We can't predict the weather the way we used to.
We have really noticed in the last 5 years these changes very, very rapidly. Even the seasoned hunters are not able to predict and read the conditions of sea ice.
By 1997, scientists and local peoples of the Arctic decided that they must act. They had to come together and provide useful and reliable information on climate change to the governments, organizations, and peoples of the Arctic region. This information would allow people to decide what should be done. Information would need to be gathered from across the circumpolar region, from expert sources that included scientific studies and credible indigenous knowledge. The Arctic Council ministers from Iceland, the USA, Canada, Russia, Finland, Sweden, Norway, and Denmark decided a report was needed. ACIA, the Arctic Climate Impact Assessment. Today, after 4 years of circumpolar analysis, the results are clear, and with them, accurate projections can be made. These are the 10 key findings.
What's different about the Arctic versus the planet as a whole is that climate change is absolutely occurring now. It's occurring on scales that we have not seen in human times, and they're 2 to 3 times faster than the rest of the planet.
Most scientists agree that the increasing concentrations of carbon dioxide and other greenhouse gases are due to human activities, primarily fossil fuel burning. The United Nations Intergovernmental Panel on Climate Change also states that there's new and stronger evidence that most of the warming observed over the last 50 years is attributable to human activities. The increasing concentrations of greenhouse gases is projected to contribute to additional Arctic warming.
We're talking between 4 and 10 degrees centigrade increase over the next basically century. Those are gigantic numbers.
The average extent of sea ice cover in summer has declined by 10 to 15% over the past 30 years.
The Arctic cools the rest of the world by various mechanisms, by reflecting radiation back into the atmosphere, by catching and storing greenhouse gases, for example, and by cooling ocean currents. Those mechanisms cool the world, not just the Arctic. So what happens in the Arctic is extremely important for the rest of the world.
The area of the Greenland ice sheet that experiences some melting has increased about 16% from 1979 to 2002. It's projected that the Greenland ice sheet could melt in 1,000 years if temperatures rise by 3 degrees centigrade.
Greenland contains enough water to raise the sea by 7 meters. That means that the sea could, under these projections, rise a meter every 50 years. And a meter is a just gigantic number. Bangladesh will lose 40% of its land mass. You can imagine what 7 meters over the next several hundred years might mean.
Increases in glacial and sea ice melt, precipitation, and river runoff add more fresh water to the ocean, raising sea levels globally and possibly slowing the ocean circulation that helps distribute the Earth's heat from the tropics to the poles. Increased sea ice melt will also enhance access to oil and gas resources. The tree line is expected to move northward and to higher elevations, with forests replacing a significant fraction of the existing tundra. Over the next 100 years, trees are projected to replace half the existing tundra. Forest fires are very likely to increase in frequency, severity and duration.
The short period of the current Arctic summer is restricted by when the snow comes and when the snow goes. And as that snow-free period becomes longer, then the season available for plants to grow becomes longer. We would expect to increase the productivity of the vegetation and allow more species to grow here that don't grow in the Arctic already.
Agriculture will have the potential to expand northward due to a longer and warmer growing season and increased precipitation. Reductions in sea ice will drastically shrink habitats for ice-dependent species such as polar bears, walrus, ice-inhabiting seals and some seabirds, pushing some species toward extinction. The Arctic climate change effects will have implications for biodiversity across the world, because migratory species such as whales and birds from other regions depend on summer breeding grounds in the Arctic.
As the forest replaces the tundra and its wetlands, then there will be less area for the birds to breed on and to feed from. There may be a potential mismatch between the timing of migration and the availability of the food sources in the Arctic.
There's considerable concern for large mammals, such as the polar bear, that depend on the summer sea ice for their survival.
If the ice is not forming, we're not hunting on the ice, but nor is the polar bear. And the polar bear depends upon seals to survive.
Summer weight loss in polar bears in the Hudson Bay area has been found to be increasing, and scientists believe that any further weight loss could result in reducing their breeding success. Caribou depend on tundra areas for their summer grazing, so the expansion of forest into the tundra will restrict these summer grazing lands. There may be reduced possibilities for caribou or reindeer to move across swollen rivers. Some marine fisheries, which provide food for the world and major contributions to the region's economy, are likely to become more productive, while northern freshwater fisheries that are important to local people are likely to suffer. Severe coastal erosion will be a growing problem as rising sea levels, river flows, and a reduction in sea ice allow higher waves and storm surges to reach the shore.
All the Arctic is warming, and as a consequence, the ice that used to protect the shores from the severe storms is not there. It's something like 143 villages of indigenous people are going to have to be moved over the next 10 or 20 years. And it's just because the ice that used to be there protected the shore, and it's not there anymore.
Changes in weather patterns are projected to have far-reaching effects.
Contaminants such as PCBs and heavy metals like mercury and lead, these are moved around on the planet by the winds and by the ocean. And if those patterns of movement are changing or intensifying, then it's going to change the pattern of the redistribution. Our models suggest that the Arctic Ocean will be ice-free sometime towards the end of this century. And that will have huge consequences, because we're talking about opening up sea routes that didn't exist before. And the Arctic will behave like our lakes. freeze in the winter, thaw in the summer, freeze in the winter, thaw in the summer. So you're going to see shipping occurring between the Far East and European markets that are 45% shorter than going through the Suez Canal. And that has huge implications. There's economic development potential. It's going to change the character. Villages are going to become towns, towns are going to become cities. As oil and gas development expands, which it was likely going to be, because there's one of the largest gas finds in western Russia in the ocean. So that's going to change the whole dynamic there.
However, if the Arctic Ocean is opened up to better opportunities to exploit oil, it's also open to increased possibilities of oil spillages and disasters for ecosystems and people. As the climate warms, then one of the first noticeable impacts is the thawing of the discontinuous permafrost.
We have permafrost melting so quickly in some regions of the Arctic that houses that are along the coast are having to be relocated as a result of that.
Permafrost has warmed by up to 2 degrees in recent decades, and the depth of the layer that thaws each year is increasing in many areas. Transportation and industry on land, including oil and gas extraction and forestry, will increasingly be disrupted by the shortening of the periods during which ice roads and tundra are frozen sufficiently to permit travel. While everybody in the Arctic can expect to feel the effects of climate change, some of the largest impacts will be felt by the region's indigenous people because of their continuing connection to their local environment.
In certain areas, glaciers are melting so quickly where there used to be streams are now torrent rivers, and we've actually had drownings as a result of that because hunters were used to crossing streams to get to the other side, and accidents happen now because it's a torrent river. So the melting of glaciers, the melting of permafrost, and the formation of the ice coming in a lot later in the year and breaking up a lot sooner in the spring is probably one of the biggest challenges that we're faced right now in the Arctic.
Adapting to new conditions is what the Inuit way of life has been for thousands of years. But this one is so rapid and will change profoundly many communities' way of life.
The ozone layer absorbs ultraviolet radiation from the sun, protecting life on Earth from exposure to excessive levels of radiation. Due to man-made chemicals, ozone depletion over the Arctic has been severe, and this may lead to increased ultraviolet radiation at the Earth's surface. Since human beings receive about half their lifetime ultraviolet radiation by the time they're 18, young people in the Arctic will receive about a 30% greater lifetime radiation dose than any prior generation.
Increased UVB radiation also has a potential to be harmful to people. It has benefits, but can be harmful if precautions are not taken, and the damage could include increased incidence of eye cataracts, increased incidence of skin cancers, particularly malignant melanoma, and a reduction in the efficiency of the immune system.
Risks to some Arctic ecosystems are likely as the largest increases in ultraviolet levels occur in the springtime, when sensitive plant and animal species are most vulnerable. A decrease in snow and ice cover increases exposure for living things normally protected by that cover, both on land and underwater. Changes in climate are occurring in the context of many other stresses and cultural and economic changes. In many cases, the total impact is greater than the sum of its parts.
increased habitat fragmentation, increased land use, increase in pollution, increases in UVB radiation. All these new environmental changes come together in a unique formulation that the Earth has not experienced before and which we project to continue into the future.
It's not only caused by what we are seeing now, by climate change, it's also caused by industrialization, globalization. The social development of Inuit in Greenland have gone through a rapid change.
The ACIA findings are vital to know, but they don't halt the growing problem. Altering the warming trend will be a century-long process. In addition, because elevated levels of carbon dioxide in the atmosphere persist for hundreds of years, the world is projected to face some degree of climate change and its impacts for centuries. What kind of political actions should be taken in order to fight global warming?
I want to increase CAFE standards. I want to encourage alternate energy sources. I want to put cap and trade on emissions. I want to set goals for reductions of greenhouse gases. There's about 50 things I'd like to do.
I'm hoping that we can have a bipartisan consensus to put into place a cap and trade system at the very least, as well as to incentivize new technologies which could really help us slow down the damaging impact that American energy use is having on the global environment.
I think that we don't have too much time to wait until we take some decisions. And these decisions really may be very serious.
It's time for action for all politicians now.
We need to improve our legislation, we need to develop our technologies, we need to have a closer international cooperation.
We have to work for new agreements and more ambitious agreements to reduce the greenhouse gases and to reduce the climate challenges.
The Arctic is now considered the health barometer for the planet. So if you protect the Arctic, you save the planet. And that connectivity has to be understood by the world.
The information we have now is going to show the rest of the world that we have to wake up and think.
The Arctic is experiencing rapid and severe climate changes, and these changes are expected to accelerate.